Okay. Okay, so here's 5.2. Okay, so back in section 410, when I first introduced an integral like this, what you did is you integrated the function. You got some new function, right, which is the antiderivative, right? So when you do that, you got what we call an indefinite integral, okay? When you get a new function, right, plus c, that's called an indefinite integral. Now today, what's going to be different is you're going to put a number here and a number here, above and below the integral symbol. Those are called your limits of integration. So the lower limit is a, and the upper limit is b. Okay, and what's going to happen is, when I show you how to evaluate that in a minute, you're going to actually get a number. You're going to get a numeric value. And so this type of integral, when you have limits, is called a definite integral. Okay? All right, so what I'm going to do is I'm going to pick up where we left off last time. And that is, at the end of the lesson, on the last page, we turned those area approximations into exact area under the curve. And I kind of stepped you through it, and I'll review it again since you might have missed it. So this is the rectangle height, right? For one of those rectangles that we drew inside the region. Remember that? And this was the what? The width of the rectangle, right? The delta x was the width of the rectangle. Okay, do you remember this? Well, I'm just kind of reviewing what you learned last time. Okay? The f of x of I was the heights or lengths of your rectangles in your Riemann sum. The delta x were the widths of your rectangles. Okay, and so then when you added up or summed a bunch of length times widths, you got a bunch of rectangle areas that you added together, right? And that gave you an approximation for the area under the curve. Okay, I know you got that because that was 75% of the lesson. Okay, and then, so without the limit, all you're going to get is a sum of rectangle areas, and that's only going to be an approximation then for the area under the curve, right? And then towards the end of the lesson, I said, well, what would happen if you made more and more rectangles? Wouldn't the approximation get better and better and better and better? Because the more rectangles you use, the better the fit, yes? And so logically then, I concluded that to get the exact area under the curve, you would need to take the limit of those rectangle sums as the number of rectangles goes to infinity. Okay? Got it? All right, and then therefore you get the exact area under the curve. Okay? All right, now this is a definition, guys. By definition, the value that you get when you evaluate the definite integral from a to b would be that exact area that comes from the limit of the sum of rectangle areas. Okay? And again, you saw this a couple times in the lesson last time. Okay, so that's the first thing here. And you saw this several times. To get the rectangle widths, in other words, to get your delta x, you take the interval length, which is b minus a, and then divide by the number of rectangles you use, right? Got it? So again, n was the number of rectangles or subintervals, and x of I could be any sample point in the subinterval. So you remember sometimes they use the right end point, sometimes they use the left end point, sometimes they use the midpoint. Well, for this, it really doesn't matter. Okay, it doesn't matter what you use because you're going to take the limit anyway as n goes to infinity. So it really doesn't matter what you use for x of I, whether you use the right end points, the left end points, the midpoint, or any other point in each subinterval. It doesn't matter because once you take the limit, you're going to get the same limit anyway. So in that case, since x of I can be any sample point, we can always use the easiest choice, which is the right end point. Okay, and again, in general, you can get the right endpoint of any subinterval by starting at a, which is right the beginning of the interval, and then adding the delta x times I. So for the first subinterval, you make I equals 1. So you're going to have a plus 1 times delta x. So for example, if you had this interval here, say from, I don't know, 2 to 3 or something, and suppose you use 5 rectangles or 5 subintervals, right? How would you get that right endpoint, guys? It would be what? 2 and what? 2 and 1/5, isn't it? Right? And how do I get that? Well, isn't that A and isn't this B? So to get the right endpoint, I would start at A and I would add what? What? Delta x, which is what? 1/5 times what? Times I, wouldn't you? So for the first right endpoint, what's I? Well, that's my first subinterval. So you'd make this a what? A 1, and you get what? 2 and 1/5, right? For the first right endpoint, does everybody agree with that? What about for the second right endpoint? What is that? 2 and what? 2 and 2/5, and how do you get that? 2 plus delta x times I, where, again, delta x is always 1/5 in this case, and then I is 2, right, for your second subinterval. So what does that equal? What does this equal? 2 and what? 2 and 2/5. Okay, so you get an idea where that formula comes from, right? Does that make sense? All right. But the bottom line is you don't have to do that each time. You know, you don't have to find each of these right endpoints. You can just use this formula. Okay, use this formula for delta x, which I showed you where it came from last time. So basically you find these two, put them into here, and then go from there. Okay? All right. All right, now, along the way, after you do that, along the way you're going to run into some, obviously you're going to run into some summations, right? Once you put in your x of I and your delta x, once you put those in, obviously you're going to be left with a summation to worry about, aren't you? And these are going to help you evaluate those summations. These are nothing more than shortcuts, okay? And again, I gave you these last time. These are nothing new. So if your summation is a summation of a constant from 1 to n, without going through the whole summation, you just know that it always equals your c times your n. If you run into that type of a summation, without going through the whole summation, what's the sum going to be, guys? What's it going to be? Your n times your n plus 1 over 2. Does that make sense? If you run into that summation, what's it going to equal? That. If you run into that summation, what's it going to equal? That. And by the way, I'm going to give you these. Okay, on the test, I'm going to give you all of this. All you got to do is know how to use it. You're not going to have to memorize any of that. Okay? Is that fair? Yes? Okay. All right, so let me do an example. It says, find the exact area under the curve y equals x squared from 0 to 1. And by the way, to find that, all you got to do is evaluate that integral. In other words, you're going from 0 to 1, so those are your upper and lower limits. And you're finding the area under the curve y equals x squared. So x squared is your function. Are you with me on this, guys? All right. And so what you want to do is visualize the area, okay, by sketching and shading the area. So what I did is this. I graphed the parabola y equals x squared. There it is. I want to find the area under the curve. What that means is the area between the curve and the x-axis from 0 to 1. So there's 0 to 1. So clearly this is what the area looks like that we're trying to find. Everybody agree? That's the shaded region I'm trying to find the area of. Everybody agree? Okay, and so how do I find it? Well, using this formula from above. Right? To evaluate this integral, what am I going to do? Well, I'm going to take the limit here. Okay, and so what's my f of x, guys? My f of x is what? X squared, right? Hey, we were just talking about you. I know. I know. It's crazy. But my voice was here. At least part of my voice was here. You saw the video when you walked in? Oh, you didn't? Oh. Yeah, I left a video.
I don't know, as you were here.
Sorry I ruined your day. Yeah. All right. Well, I'll see you later. Stop by later. Okay. That's it. Okay. He's permanently part of it. Okay. All right. So you've got the function. Obviously, a is 0, b is 1. No big deal, right? So how do I find delta x then? By taking my what? B minus my a, which is 1 minus 0, which is 0, divided by my n. Now, you're not finding a Riemann sum, so I'm not going to tell you how many rectangles to use. You're just going to leave it as n. Is that clear? Okay. So you end up with just delta x is 1 over n. And then what's the formula for the right endpoint for x of I? Well, it's a plus your delta x times I, which in my case is what? What's a? 0 plus my delta x, which turned out to be what? 1 over n times I. Got it? And by the way, when you simplify that, what do you get when you simplify that, guys? That just simplifies into what? I over n. So I've got that. All right, so everybody with me so far? I found my delta x. I found my x of I. Okay, and I'm going to continue this on the next page. All right, so again, I just kind of updated it. I just found this a minute ago. I just found that a minute ago, and clearly my function is f of x. Any questions so far? All right, now I'm just going to put all this, okay, into my formula. Now, in my formula here, obviously I don't need just x of I, I need what? F of x of I. So what I did is I took my x of I here, and I plugged it into my function, which is y equals x squared. And what do I get when I plug that into my function? I end up with what? I squared over what? N squared. Okay? All right, so here we go then. I can now replace f of xi with that. I can obviously replace delta x with what? 1 over n, right? Everybody agree with that? Everybody following me? And by the way, what do I get when I multiply those? When I multiply those together, it turns into what? I squared over what? N cubed. Now remember, n is a constant, isn't it? I don't know what it is, but it's a constant. And you learned last time, or maybe you learned last time, that with a summation you can pull out constants. So can I pull out the n cubed if I want? Sure. So I just pulled it outside the summation. See that? I just pulled out the n cubed as 1 over n cubed, right? And that left me with what inside the summation? Just what? Just what? I squared. Following me? All right, now watch this. Watch this. Look at that right there. What is the value of that summation? Well, flip back to those 4 shortcuts. Ready? Flip back to the shortcuts. What is the summation of I squared from I equals 1 to n, guys? What is it? What is it? I can replace that with what? That, can I? Everybody agree? Sam, please, heads up, because you're falling asleep. Up, 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 up. Everybody agree I can replace that with that? Yes? Okay, so that's what I'm going to do right now. I'm going to flip it back. So there it is, right there. Got it? And obviously I still have my 1 over n cubed. Any questions so far? All right, now, what I did is I FOILed here. Okay, if I FOIL those binomials and then distribute the n, don't I get 2n cubed plus 3n squared plus n when I do all that? You following me? Okay, that's just algebra 1. And then obviously on the bottom I've got 6 times that, which is just 6n cubed. Okay, so now I'm here. Any questions on how I got to there, guys? All right, now can you evaluate that limit? You sure can, because you're taking a limit as n goes to infinity of a polynomial with the same degree. So can't you use the shortcut where you take leading coefficient over leading coefficient to get the limit? And what does it turn out to be? 2/6 or what? 1/3. So what that means is the value of that definite integral is 1/3, which is also the what? The area under the curve from 0 to 1. So see that area right there, that black area? What's that area of that black shaded region? 1/3 square units. Does that sound reasonable? Does it? Yeah, it does, because look at it. I mean, if you drew a rectangle, a huge rectangle, what would the area of that rectangle be? 1. So does that sound reasonable that that's about 1/3? Does it? Yeah. I mean, my drawing's off a little bit, but I think it's reasonable that it's 1/3 square units. Does that make sense? Okay, so I now showed you how to find the area under a curve when you can't use a geometry formula. Does that make sense? Okay? Obviously, that's not a nice geometric shape. So that's why you need calculus to find the area. Does that make sense? If it was a nice geometric shape, I could just use some geometry formula, right? Okay, do you understand what we're doing here? Okay. All right, now watch this, guys. The shaded region in example 1 was above the x-axis, wasn't it? So you can kind of look at that as being positive area, but never say that on the AP test. It's just a way of looking at it. When the area is above the x-axis, it's always going to turn out to be a positive value for your definite integral, which is why you kind of call it positive area. Okay. Now, what you're going to see at some point is that when the region is below the x-axis and you evaluate the definite integral, it's going to turn out to be a negative value. So I kind of call that negative area, even though there's no such thing as negative area. You can kind of think of it like that. So what I'm saying is this. Suppose this is your function, and you're going to integrate that function from a to b. Well, again, what is the value of the integral? It's the area between the curve and the x-axis. So wouldn't you be finding this area and adding it to this area and adding it to that area? Wouldn't you? Yes? If you integrate from a to b, it's just the same as finding those 3 areas. Now again, that'll be positive when you evaluate it. That'll be what? Negative, and that'll be positive. So when you add those 3 values together, it'll give you the whole integral from a to b. Does that make sense? Okay? So again, if you integrated from here to here, you'd get some positive number. If you integrated from here to here, you'd get some negative number, a2. And then when you integrate from here to here, you get some positive number, a3. And then when you add all those together, it's the same as integrating all the way from a to b. Does that make sense? Okay? So basically, there it is, right there. Got it? And again, you subtract a2. Why? Because it's what? It's what? Below the x-axis, right? And by the way, if you didn't notice, I kind of assumed that the following thing is true. Ready? So look at this picture. Notice that I'm talking about integrating from a to b, and what I did is I stuck some number c between a and b. Okay, so again, I just stuck some number c between a and b. Well, if you integrate from a to c by finding this area, and then integrate from c to b by finding that area, and then add them together, isn't that the same as integrating all the way from a to b, isn't it? And so that's all this says right here. If you integrate, why did I just get a message? I heard my phone ring. Anyway. When I integrate from a to c and add that to what I get when I integrate from c to b, that should add up to the whole integral all the way from a to b. Does that make sense? Yes? Okay. Now, the way I drew it, I drew c between a and b. But believe it or not, even if c was way out here, this would still work, believe it or not. You might not be able to see it, but trust me, it does work. Okay? So even though I drew it with c being between a and b, even if I stuck c way out here, it would work writing it the same exact way. Okay? And I think you'll understand later why it works, but just know that right now it does work, no matter where c is. So even though I drew it with c being between a and b, c really does not have to be between a and b. All right. All right, so now we're just going to do a couple more examples. And I've got a quick thing to show you at the end, and that'll be it. Okay. All right, why don't you guys at least see if you can set it up. Don't finish it, but at least go through here and then stop after you set this up, okay? See if you can do that on your own. I already drew the parabola for you. Just notice that all I did is I graphed the parabola y equals x squared plus 1, since that was my function. Is everybody okay with that? That I graphed the function right there? Okay? All right, so now you take it from there. First of all, shade the region so you know what we're finding. Shade the region first. Shade the region first, and then go to your formula. Just seeing if they sent me another message for some reason. No. I don't know. Don't remember. Oh, okay, that's fine. Sorry, I just don't remember. There's so many tags. Again, I gave you everything you need right there. Just put everything in. I don't think you need to look back yet at the old example. I gave you everything you need right here. I just rewrote it for you. Yeah, once you find all this stuff, guys, here, go ahead and put it into there and then stop. We'll finish it together from there, okay? So just find all these, put them into here, and then stop. Got it? By the way, if you haven't started already, start writing small. There's going to be lots and lots of steps to finish it. I need everybody to get to there because this is the only one we're doing. And so if you can't do it on your own, you're not going to be able to do it on the test next time. So again, I need everybody to get to that step that I mentioned and then stop. Okay. Ready, guys? All right, so first thing you want to do is graph your function, which is what I did. Look at your limits. What are my limits? 2 to 4. So the area we're going to be finding here in a minute is this area right here. Everybody agree? We're going to find that exact area of that region. Clearly, it's not a nice geometric shape, is it? No. So we're not going to be able to use a formula. So we're going to have to use calculus, right, to find that area. All right, so here it goes. Well, delta x, which is your width of each subintegral, can be found by taking your b minus your a. And so what's that, guys? Quick, tell me. What is it? Let me just call on you guys. How about, I don't know. Let's see here. Shunhee, what's your b minus your a? Okay, now be careful. N is the number of rectangles or subintervals, right? But I didn't tell you what n is, and so you're just going to leave it as n. And then so doesn't that turn into 2 over n? Okay, n is the number of rectangles in your Riemann sum. We're not doing a Riemann sum. We're finding the exact area. Riemann sum is if I tell you the number of rectangles to use, you're going to get just an approximation for the area. That's not what we're doing today. We're going beyond that. We're finding the exact area under the curve. So you're not going to have n here. You're just going to leave n as anything, right? Just n. All right. Now, x of I can be found using this formula. And so what's your a, guys? What do I replace a with? 2. Plus your delta x, which you just found to be 2 over n, and then times I. Is everybody with me on that? Okay, and by the way, I'd like you to just turn that into this. Do not get a common denominator on that. Just leave it like that for now. Okay? Are we clear? Again, do not get a common denominator on this yet. Okay? Just leave it alone. All right, now what do I got to do with the x of I? I've got to plug it into where now? F of x, to get f of x of I, right? So I take this and I put it into my function. Is that clear? Okay, so I'm going to put it right into there. Got it? So I'm going to have x squared plus 1, where that goes here, right? Everybody with me on that? Yes? Okay. All right, so now, to evaluate that integral, which is the area under the curve, right, from a to b, all I got to do is find this limit. Yes? Ready? Here we go. So I'm going to take the limit as n goes to infinity of the summation I equals 1 to n of f of x of I, which I just found to be this, right? Isn't this my f of x of I right here? Times what? Times what? Yeah, delta x, which is what? What's delta x? 2 over n. Any questions on where any of that came from? All right, now it's just a matter of finding this limit, okay? It's going to be a lot of work. Are you ready? Let me finish just on another sheet. Write myself a note, so if anybody borrows these notes, they'll know I finished it on a separate piece of paper. Okay, so here it goes. All right, so what are we going to do here? Well, first thing I'm going to do is FOIL here. Yes? Everybody agree I'm the FOIL there? Okay, so if I FOIL there, I get what? 4 plus what? 8i over n, yes? plus what? 4i squared over n squared, right? Don't lose your plus 1. That's a common mistake that students forget to put the plus 1 after they FOIL. And by the way, if you want, you can combine the 4 and the 1, can't you? Yes? Combine that into 5 if you want. No big deal, right? Any questions so far? By the way, I still have these. If you want to do that, I'm okay with that. Instead of continuing to copy those, just do that. That'll be fine, right? Following me? Yes? So I still have the limit and the sum. Are you writing it down? Yeah? Got it already? All right. All right, now what? What do you think we should do now? Do what with this? Distribute it. Everybody agree that makes sense to distribute that? Yes? So I'll bring this down again. That gives me what? 16i over n squared plus what? 8i squared over n cubed plus what? 10 over n. All right. Now, there was a property in your notes last time that said when you have a summation and then you have a sum or difference inside the summation, can I split this up into 3 separate summations if I would like to? Yep, that's what I'm going to do. Okay. Yes? I guess you could, but I'll tell you, I mean, this is the way I'm going to do it on the test, and you're going to have to follow and pick the correct step on multiple choice, so I wouldn't do that. Just kind of do it consistently like I do. Okay? All right, now, look at each of these summations. What's a constant there, guys? What's a constant that I can pull out of that summation? What can I pull out? A 16 over n squared. That leaves me with that, doesn't it? What's a constant there that I can pull out of that summation? 8 over n cubed. Right? And then finally, what can I pull out of there that's a constant? 10 over what? N. That leaves me with what? A 1 there? Yes? Okay. All right, so all right, let's look at this now. Ready? To evaluate that summation, is there a shortcut formula for that? Is there? Yeah, right here. What is it? I can replace that with what? N times Sam. Come on now. N times what? N plus 1 over 2. Okay, everybody with me on that? Yes? Okay. Is there a formula for that? Is there? Yeah, what is it? I can replace that with what? That? N times n plus 1 times 2n plus 1 over 6, yes? And then, what about that summation right here? Is there a formula for that one? Yeah. 1 is just a constant. So doesn't that fit this one right here? So what does that equal? That equals your constant times your n, doesn't it? Everybody agree? Yes? So what is it then? 1 what? 1n, yes? Okay. All right. So here we go. Here's what I'm going to do. I'm going to distribute the 16n there, and that gives me what? 16n squared plus what? 16n over what? 2n squared, yes? Everybody agree with that? Okay, here what I'm going to do is I'm going to FOIL, and that gives me what? When I FOIL there, I get what? 2n squared plus what? 3n plus 1, yes? And I'm going to distribute the 8n, and that gives me, careful, 16n cubed plus 24n squared plus 8n all over 6n cubed. And then here I get what? Yeah, the n's cancel, I just get what? 10. Everybody agree? Yes? All right, guys. Now, I'm going to split this up now into 3 separate limits. Any questions? Is this good or no? Yes? So that I can evaluate them separately. Okay, so let's evaluate these limits now. This is our last step and we're done with this. You're taking a limit as n goes infinity of a polynomial where they both have the same degree, don't they? And so what's the limit? Isn't it leading coefficient over leading coefficient? So what does that equal? Okay. What about this one? Same situation, right? You got a polynomial over polynomial, same degree. So isn't it leading coefficient over leading coefficient? 16 over 6, which is what? 8/3 or 2 2/3. Yes? Everybody agree? And then what's the limit of a constant? It's constant. So what do we get here, guys? 20 and what? 2/3 square units. Yes, but when you're evaluating an integral, you don't really need the square units. So just say the value of the definite integral is 20 and 2/3. Yes? Yeah, you could have gotten a common denominator in here and then taken one limit. That's fine. But again, be aware that the way I'm going to test you on this, on the multiple choice, is I'm going to have a bunch of these steps. And I'll say, I'll give you some choices, and I'll say which of these choices is a correct step in the process. So you'll have to probably do it the way I did it to pick out the right step.
But it wouldn't be wrong.
It wouldn't be wrong, like if you did it that way on your homework. No, that's fine. Just make sure you can do it this way on the test so you can pick out the right multiple choice answer. Is that clear? Okay. Okay, so it's grueling, I know. I'm not going to make you do many of those. I think I gave you 2 or 3 of those on your homework. That was it, okay? All right, so. All right, now the rest of this is going to go pretty quickly. Ready? All right. Suppose I had given you an integral. You graphed the function, you shaded the region, and you noticed, hey, my region under my curve is a triangle or a rectangle or some other nice geometric shape. Would I need to go through all that limit stuff I just went through? No. I could just what? Use one of these formulas from geometry, couldn't I? Yes? That's a what? Triangle, rectangle, circle, trapezoid, right? So if your region is any of those shapes, clearly you can just use those formulas rather than going through that 20-step process I just took you through. Everybody agree with that? All right, so let's look at some examples. By the way, remember I said this keeps coming up, and this is not the last time it's going to come up. It's come up at least twice already this year. It's coming up today. It's going to come up again in a future chapter. You need to recognize the equation of a circle. X squared plus y squared equals r squared, as you remember, is the equation of a circle. And if you solve for y, don't you get this? And the positive square root is the what? Top half of the circle. The negative square root is the what? Bottom half. And again, r is your what? R is your what? Radius. Okay, so remember that. Okay. So anyway, here's an example. Suppose I ask you to evaluate that integral. What's the first thing you're going to do always? Graph it. Okay, so what did I graph? What's the function I graph? Y equals x minus 1, which is obviously this line right here. Yes? Everybody agree? Yes? Isn't that the line y equals x minus 1? And then I want to shade the region under the curve from what? 0 to what? 3, which is what I did. Here's 0, here's 1, here's 2, here's 3. So I notice what I did. I shaded the regions between the curve and the x-axis. Yes? Are you following me? Okay? Anthony, heads up. Up, 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 up. Thank you. All right, so clearly, my regions are what? My regions are what? Triangle. So do I need to do all of this stuff right here? Do I need to do any of this to find the area? No. I can just use geometry, yes? Okay, so what I did is I did 1/2 base times height for this triangle, and then 1/2 base times height for that triangle. And why did I put a negative on that first one? Why? Why did I put a negative on that area? Because it's below the x-axis. Is that clear? Are you with me? All right. And so, by the way, what is the base and the height here? 1 and what? 1 and 1. What are the base and height here? The base is what? 2, and my height is what? What is it? 2. And so when I simplify all that, I get that, which is just 3/2 or 1 1/2. Yes? Everybody agree? There you go. Any questions? Pretty easy, isn't it? Okay. All right, what about this one, guys? What does that look like? What does the graph of that function look like? Yeah, it's the top of a circle, right? With what? With radius equaling what? 2. Everybody agree? Because that's r squared. So if r squared is 4, r has to be 2. Everybody agree? So draw it. Everybody draw the top half of a circle with a radius 2. Everybody agree that's what it looks like? Isn't that what the graph of y equals square root of 4 minus x squared looks like? And what do I want to integrate? I want to only integrate, though, from what? 0 to what? 2. So that's the area I want right there, only from 0 to 2. Is that clear? Yes or no? That I want to find that purple area? Yes? What's the shape of that purple area? What's the shape of the purple area that I'm trying to find the area of? A what? Quarter circle, isn't it? So to evaluate that definite integral, I'm simply going to take 1/4 pi r squared, right? Where the radius is what? 2. And so what do you get there? Pi? You get about 3.14 or so. Easy, isn't it? Yes? Okay. So it's only when you don't get a nice geometric shape that you got to go through all that limit of the summation stuff. Is that clear? Okay, last page, just to go quick. Looks bad, but it's not. All right, all these are a bunch of properties. And once I introduce them to you, I expect you to use them throughout the rest of the course. They're real quick and easy. Ready? I typed them up for you so you don't have to write anything down. Here it goes. Ready? I'm going to fly right through them. What does this say, guys? Real quick. You can always switch the limits if you need to, as long as you do what? As long as you put a negative on the integral. Is that clear? So you can switch the limits on a definite integral anytime you need to, as long as you what? Put a what? Negative out front. Okay. What does this one say? If you integrate from a to a, in other words, if your upper and lower limit are the same, think about it. If you start and stop at the same x value, does a region ever even get formed? No, it's just a flat region with an area of what? 0. So that one's common sense if you think about it, isn't it? Yes? What does this one say? If you have a constant c inside of a definite integral, you can do what? Pull it out. What does this one say? Well, that was the one I referred to earlier. Do you remember this stuff right here? Remember that from earlier? Well, that's the same thing here. What it says is if you integrate from a to c and then pick up at c and then integrate to b, when you add those two areas, it's the same as finding the area all the way from what? A to b. Got it? So it's, again, kind of common sense if you think about it. What does this one say? If you have a sum or difference inside your integral, what can you do? You can split it up into what? Two separate integrals from a to b? Yes? Same thing with a difference, yes? If you have a difference inside your integral, you can just split it up into two separate integrals from a to b if you'd like. And then what's this one say? If f is greater than or equal to g, then what? The area under f has to be greater than or equal to the area under g. Does that make sense? That's common sense. Think about it. If f is greater than or equal to g, in other words, graphically it's above it, won't the area under f from a to b be greater than the area under g from a to b? Isn't that common sense? If f is greater than or equal to g, in other words, it's higher, won't the area under the curve be greater than or equal to g, the area under g? Does that make sense? Yes? Won't the red area under f be greater than or equal to the purple area under g if f is greater than or equal to g? Does that make sense? Common sense, isn't it? Yes or no? All right. Let's do these last three and we're done. Okay. All right. So I'm telling you that that is what? The area under f from 0 to 10 is what? 17. I'm giving you that. I'm also giving you that the area under f from 0 to 8 is what? 12. I'm also giving you that the area under some other function g from 0 to 8 is what? 6. So that's what I'm giving you. So with those three pieces of information, along with the properties of the integrals I just went over, you should have no trouble finding these three values. Are you ready? Ready, Anthony? Okay, here we go. All right. Any idea how I'm going to find the integral from 8 to 10 of f? Well, again, these are the only ones that involve f. How are you going to do it? Well, think about it. If you integrate from 0 to 8, and then you pick up at 8 and integrate from 8 to 10, when you add those two, it should add up to what? It should add up to what, guys? The integral all the way from what? All the way from what? If you integrate from 0 to 8 and add what you get when you integrate from 8 to 10, isn't that the same as integrating all the way from 0 to 10, guys? Isn't it? Yes or no? Yes? Okay. All right, now, don't I have this? Yeah, that's given to be what? 12. Put it there. This is what I'm looking for, isn't it? So leave that alone. And then do I have this? Yeah, that was given to be what? 17. So, can I solve for that now? What do I do to solve for that then? Subtract 12. And I get that the integral from 8 to 10 is what? What is it? 5. Not too bad, is it? No? Okay. Who can tell me what to do on B? Yep. This goes from 10 to 0, but I know what the integral is from 0 to 10. So like you said, put a negative on it, and that allows you to what? Switch the limits. Sam, are you with me? Okay, yeah. Everybody see what she did? She switched the limits, and you can do that anytime you like as long as you put a negative on the integral, right? Does that make sense? And now, don't you know what that is? Yeah, aren't you given that? What is that? 17. So what's my answer? Negative 17. Easy, isn't it? Yes? Any questions? All right, one more. One more. All right, well, what did we say? When you have a sum or difference inside your integral, can't you split it up into separate integrals if you'd like? So that's what I'm going to do here. And by the way, isn't there another property that allows me to pull out that 2 if I'd like? Isn't there? Okay. You guys should be writing these down so you have something to look at. All right. All right, so that's as far as I can go as far as using my properties, right? Now, do I know this? Do I? Yeah, that was given to be what? 12? Yes? And I got 2 times this integral, right? Do I know that integral, guys? Yeah, that was given to be what? What's the integral of g from 0 to 8? What is it? 6. So what do you get here, guys? 4. We good?